it's my pleasure to introduce our next speaker, Peter Marx. Peter is the Vice President of Advanced Projects at GE Digital. Welcome to Peter. Peter was the former CTO at the City of Los Angeles and also former CTO of World of Warcraft.
That's right.
Okay. All right.
See, I
thought that would get your attention. Peter, welcome.
Which one's bigger, Los Angeles or World of Warcraft? So thank you very much for having me. It's sort of fun to come up here and give a talk at Berkeley. I'm going to talk about open data, closed data. I think we just had to talk about closed data. Data you can almost get to, you can see, but you can't quite get to. And then, in addition, we'll talk about what's happening with industry across the world, IoT. And so with that, I thought I would have a little bit of fun and just literally frame the problem that we're dealing with really across the world. Although this is, GE is so big that, it's actually a good mirror, if you will, for industrial issues across the world. I mean, to give you an idea of the scale of General Electric, GE generates around 11–12% of all the power in the world. If you took an airplane, I heard that people came all the way from Taiwan, I think it was, maybe even further. And so, 60% of the turbines on the wings of airplanes, those jet engines, are produced by GE. If you've had a scan in a hospital, like an MR or CT ultrasound, chances are pretty good that it was from GE, et cetera, et cetera, et cetera. And the essential problem that we're dealing with at GE is the following. Productivity, however you measure it, productivity of the world, industrial productivity, for many, many years increased pretty reliably, 4% year over year. But for the last few years, it really hasn't increased at all. And there's a lot of theories about that. Have we reached really what we can do with metals and processes and chemical engineering? Maybe, maybe not. Have focusing on individual machines caused us to get so myopic that we made the machines incredibly efficient, but the systems are not, right? And so what this really has led us to do is to go and say, okay, we need a new set of tools. This is not going to come as a surprise to anybody in this room. We need a new set of tools from the digital world, which we can then apply to the more traditional infrastructure, the more traditional physical world issues, right? This is not to say, by the way, industry, cities, all these things, they're heavily computerized. These people are not dummies. They've been using computers forever, right? But what we have now is that we have some really ancient neural network algorithms that were developed 30 and 40 years ago that are now coming to life, if you will, because, well, there's now data, more data coming from sensors, right? If you think about things like ImageNet, really powered computer vision, the algorithms, it's funny, I used to run R&D at Qualcomm, big chip company. The algorithms in computer vision haven't really changed a tremendous amount. But what's happened is that we now have a tremendous amount of data to inform those algorithms. And the same thing is now beginning to happen in the industrial space. You start to say, well, I can connect up all those big important machines to the cloud, and I can start to do things. And we're seeing this happen. Literally we have buildings and cities filled with lights that are now connected to the net. I'll give you an example from LA. We replaced all of the streetlights across the city. 218,000 streetlights are now mesh networked, individually controllable, and instead of an on-off switch, literally turning on all the streetlights at once, they deliver light as needed. It has sort of an interesting effect because not only did it change the look of the city and reduce the power bill, obviously, but then in addition, it also does things like it allows those light poles to now be used for other things. So there's 20,000 EV chargers going across the city, right? So I have an electric car, probably a bunch of people here do. It's sort of like your laptop, you just plug it in at night. And there are tons of parking spaces now across the city where you can literally park in front of a street light and use the excess power to charge your EV. Really simple things like that. And then, of course, environmental monitoring and all the rest of it. So it's always fun to come up to the Bay Area and talk about LA, by the way. It's just kind of fun. Usually it's even more fun when I do it in San Francisco, by the way. But Berkeley is pretty good for this. You guys may or may not have heard that LA has traffic. And traffic has been around for a long time. In fact, you can't really see it, but hiding behind there on the right is actually LA City Hall. This is a picture from, I don't know, the 40s or the 50s. So they used to, and I'm going to talk about open data and infrastructure and how data is changing literally daily life. So they used to do the following. LA innovates. I know that may seem sort of funny, but I'll just say that we innovated in a lot of ways. One of the ways that we innovated was that we sent up traffic helicopters, which started in LA. So they would send a helicopter up and they'd fly around and they would report on the traffic. Because after all, what better way to get a sense of what was going on than to look at it from above? And it worked. You still have helicopters running around cities reporting on traffic. But there are better ways. And in 1984, with the Olympics in LA, they started to create a system called ATSEC, which is the Automated Traffic Surveillance and Control System, which is, it's sort of hard to see, but basically it's a room of monitors and radios and control stations. And in 1984, what they did was that they started to literally put digital controls, right, automatic controls, onto the stoplights. By the way, you probably didn't know that the first automatic stoplight was also in LA. And what ended up happening was that they would start, we call it traffic, stoplight synchronization. And so it's a little bit more sophisticated. But over the subsequent 30 years, they deployed the system to 4,500 intersections, 45,000 stoplights, right? There are about 10 per intersection, about 23,000 loop detectors on the roads, and maybe 1,000 cameras. And the entire system load balances across the stoplights once per second. So as traffic is going around LA, it literally, the stoplight timing for the stoplights literally changes at a 1 hertz rate. And the reason why is because if there's more traffic going northwest, north-south, east-west, whatever it happens to be, through the various sections of the city, the lights will balance themselves to reduce the trip time. And the system produces, it's sort of hard to measure without turning the whole thing off, but you guys are a bunch of statisticians. Our estimate is that it saves about 17% on trip times. And it has an impact on environmental too, right? The less time you're waiting at the light, the less time your car is idling, emitting carbon, right? The less time you're sitting in your car, believe it or not, the more time you get to do other things, like watch Netflix, things like that. And so it's not a big surprise. When I became the CTO for the city, I sort of looked at this room, which by the way is in the sub basement underneath the building. I mean, it's literally a cave. Like, it's the control center for the city, as far as I'm concerned. And so, well, how do we get the data out of this, right? Because it's sort of this fantastic thing, if you will. It shows literally the flow of people and vehicles, logistics and packages, cars, trucks, everything. By the way, it handles, cars. It also handles light and heavy rail. It handles, the bicycles, the pedestrians. There's even 10 or so stoplights that handle horses, just to give you an idea. But today, people navigate with Waze, right? And the trick is, in LA is the biggest market that Waze has, not surprisingly. About 40% of the drivers use an app to get around the city. How many people here use Waze? Anybody? Okay. That's about right. I'd say it's about 60% in this room. Well, Waze is the new interface, if you will, into the traffic system. Because think about it. The old way of dealing with traffic is that you put up a colored light, right? Invariably it's green, yellow, and every time I show up at an intersection, it turns red. And then we have literally on the surface of the roads, we put paint. And then to tell people really useful information, we paint signs, right? This is not a modern user interface by any stretch, for handling traffic. This is a much more modern interface. And what it allows us to do, and this is a screenshot of one of the computers, one of the interfaces to ATSEC, But this is LAX. Here's a roadway at LAX, and underneath it, you can see this is the central terminal area of LAX, showing all the stoplights and everything else. And all of that data can then be surfaced, out of that system, if you will, through some mechanism, right? And that's where IoT is really going. And so what you end up with is you end up with things like this. So this is a screenshot of Waze, and various things that allow you to go and say, okay, I can take the data out of ATSAC, and I can throw it into an application like this. In fact, I'm going to have a little fun. Unlike the previous speaker, the data that drives all this is free. Anybody can use it. Go to data.lacity.org, or there's two. There's the tabular data is at data.lacity. There's geographic data, GIS data, at geohub.lacity.org. There's a couple thousand data sets, and they're all available for free. You can use them for anything you want. Full stop. It's kind of cool. So they're actually the top-rated open data portals in the country. But what it allows you to do is the following. Unusual traffic, it'll route you around things. And oh, by the way, because we have so much now overlapping correlative data, between things like traffic collisions and geographic information, that we can start to do safety alerts. We can start to say, hey, put up a safety notification, for example, around a dangerous intersection. By the way, the transportation engineers go nuts whenever I say a dangerous intersection, because intersections are never supposed to be dangerous, right? But obviously, that's an issue. How many people here have run into this situation? Construction, like the construction signs showing up after you run into the traffic jam. Anybody? Well, it turns out that modern cities have a GIS system. LA runs on a GIS system and has for a long time. In fact, the guy who founded a company called Esri, some of you are probably very familiar with, his first job was actually working for the city of LA. And so the city maps every street closure, everything, every reservation for public works, every sidewalk closure, every street closure, every film shoot, every farmer's market, everything into this. This data is, of course, now available too. And what it means is that if you use, TomTom, Apple Maps, if you use Google Maps or whatever it happens to be, to route yourself around, all of this data now routes you around things like construction. Really straightforward stuff. But if you will, the reason why I bring it up is because we are now seeing huge amounts of data that are coming from urban settings that we've just never seen before. And they have a direct impact upon all of our lives. Similarly, how many people here have ever gotten a parking ticket? Anybody? Yeah, scourge of my life. In fact, when I was at UCLA, sorry to mention it, but when I was at UCLA, I once had so many parking tickets that were actually almost the same size as my tuition. But that was when tuition was really... So we also, along the lines of IoT, Internet of Things, all the parking meters in the busiest sections of the city, downtown LA, Westwood, Hollywood, and so on, they're all connected to the net. They all report their availability. They all have dynamic pricing. You can literally pay for your meters, of course. By the way, San Francisco launched the same thing at the same time. It's just that you have the scale is just different. And part of the challenge that we have up in the Bay Area is that there are a lot of cities up here in 5 counties, right? I lived up here for 10 years, and I can tell you it's just a more complicated space. But you can see where all this stuff is going, right? When the infrastructure of a city starts to make its data available through APIs, that means that by definition, we can start to do really interesting things with it, right? We can start to do social economic analysis against hard data that has just been unavailable before. And to go back to those open data portals, every crime that's reported to the police, every pedestrian or traffic stop by the LAPD, every arrest, every parking citation, every one of these things is published to the net. It's literally made available. for anybody to use. Every ship that comes into the harbor, every building permit that goes out there. And you start to be able to go and say, now I can have literally a view of a transparent city where I can look at daily life, in a way that we've really never been able to do before, to go and address real issues. And of course, this is laying the foundation for, the future, which is we're about to see some huge changes to our daily life. In case you haven't noticed, probably a number of people up here have talked. You've probably heard of things like connected autonomous vehicles, right? Self-driving cars. Well, those are coming. And I'll put it in the following way. When I was at Qualcomm, KPMG came in one day and they said, there's this thing that's coming down the pike. It's called self-driving cars. We're like, yeah. And they had, but remember, how many people, before I start slamming consultancies, how many people here work for a consultancy? Okay, so I'll be nice. So KPMG came in and they said we were doing focus groups on whether Americans would be interested in self-driving cars. And they ran a focus group in the Midwest. And the focus group sort of said, yeah, I'd try one. Sure, why not? The focus group on the East Coast said, oh yeah, I'd be interested. I would definitely like to get into one. I might even consider getting one or regularly using one. The focus group on the West Coast, not surprisingly, said, can I get it today? As they said, it literally got a bit out of control. Well, nowhere is that more true than a place like Los Angeles. LA, I worked on the Uber and Lyft deals for the airport, for example. And there's probably nowhere in the US that is more synonymous with cars, but also more synonymous with changing from cars to different types of mobility, right? There are 4 rail lines under construction in LA. LA is the biggest market for Uber and Lyft, as I mentioned. It's also, paving bike lanes and putting in protected bike lanes and doing more at a greater scale than probably anywhere else in the country. Because, in fact, the city, we all know how hard it is to pass a tax bill in the United States, especially in California. But the city literally committed to funding indefinitely public transportation in the last election. They also, by the way, funded 2 bonds on addressing homelessness, right? But on the public transportation side, the city literally with a 70% margin said we are going to fund having alternative vehicles forever, right? Alternative forms of mobility for literally forever. And so when you get into, this is the mayor about to get into a self-driving Volvo to be driven over to the auto show, which was sort of fun, by the way. But, if you will, all the stuff that the city is doing is really a layup for these sort of future things. And you can start to see other indications of it. This is a project that we did with Google. And what it is that we wanted to create a one-to-one relationship between you and the city. Remember I mentioned painted signs and painted roads as being the user interface? Well, this is a very impersonal interface to the transportation system. Well, your mobile phone allows for an opportunity for you to have a one-to-one relationship with literally the city, the area around you. And so what we did was that not using any personally identifiable information, but if you work, live, visited city of LA, depending on where you were, we told you different things through Google Now, or we put it into the search results. So for example, if it's going to rain tomorrow, we'll tell you today to remember to turn off your sprinklers, right? Remember we're doing this during the drought. If there's an opportunity, if there's something of interest to you, it turns out that backyard beekeeping turned out to be a very controversial thing. By the way, it passed. Then you can go to the city council and comment on the fact that the city council's discussing whether you can keep bees in your backyard. And similarly, if we're going to close a big street, then we'll tell everybody around that street, anybody within that geofence, that the street is going to be closed tomorrow. Very, very straightforward stuff. But literally to allow for a personal experience against the city. Okay, so now let's step back. Now let me put on my other hat, if you will. Now let's talk about the world's infrastructure, right? How are we addressing that sort of stuff? Well, that, as I've tried to take you through in the city of LA, a lot of these things are bespoke applications that were developed by groups of people literally to solve one systems issue at all. Across the city of LA, there are 1,400 applications that run the city of LA. It just is what it is. And open data literally consists of saying, let me take the data from those applications and put them in a open data portal, a data abstraction layer, so that people can then get to it, right? Well, we have the same issue happening in industry across the world, right? You have, this is a power system, the control room for a power system. And you can see, obviously, if you've ever been in big infrastructure, whether it's a control tower for an airport or the control system for a power plant, they're all computerized, right? And they're spread across the world, right? We have things like oil rigs in the Gulf of Mexico or the North Atlantic. There are places like airports and big industrial spaces and all the rest of it. And the challenges that we have with getting data out of those systems are actually really almost an order of magnitude more difficult than getting it out of a dense urban environment. And so what we're doing at GE is the following, which is that we're saying, okay, look, let's build a platform. Let's in fact, if industry is going to go and get digital, let's build a platform that allows us to really go and just address the issue comprehensively. And we call it Predix, by the way. And our belief is the following, which is that such a platform has to be very different than, let's say, the consumer-oriented platforms that have been built so far, right? Cybersecurity is obviously front and center. Support for literally being able to run advanced analytics, from classic analytics all the way up to neural networks and everything else, has to be really endemic within that platform. And similarly, there's a whole bunch of issue around data sovereignty. If you will, we run into the following thing. A lot of people say the consumer internet, if you think about it, the consumer internet is really something where data, we've all given up our data. We have no defense against the large search companies or the social media companies or anything like that. We click on that EULA or the end user license agreement, which I'm sure that all of you have read, right? And passed by your attorney and submitted changes to the company for and all the rest of it. But when you finally do click on that thing, you essentially give up your rights, right? Well, in the industrial world, all of that data is protected, of course, by lawyers and regulation. We work in a very regulated set of industries. And so the type of work that we have to do around data sovereignty is really quite huge. I'm in Saudi Arabia next week. Well, I can tell you the Kingdom of Saudi Arabia does not want its health records to go to America. Any more than America wants its health records to go to, South Korea. It's something that we simply don't want to have happen, right? For a whole variety of sovereign regulatory issues. And the same thing is true for aviation and power and everything else, right? And so GE, we're dealing with data sovereignty by literally saying, across these different industries and across these different regions in the world, we have to build a platform that can associate that. And similarly, we're also very much into, if you will, some concepts that really weren't possible up until now. I'll give you a simple one, a digital thread. A digital thread is, can I follow, I'll pull this water bottle as an example. Can I follow the ingredients that were used to make this water bottle all the way through manufacturing and distribution? Can I, in fact, build a model where I understand the seigniorage, where the history of the manufacture of this water bottle? Now, this water bottle is not that important, but that jet engine is. And every time one of those things fails, they go through and they go literally saying, what's the root cause of the failure? And in aviation, almost every part has a serial number. However, we all know that hiding behind that serial number is paper, right? People pass paper back and forth, as they inspect, manufacture, et cetera, that jet engine. Well, we're moving to a digital thread model. And similarly, for things like that root cause analysis, being able to do time series analysis is key to everything that we do. And it's really quite simple. We now take more data that comes off of these big rotating machines, or even simple things like, for example, we have a customer named Schindler who has more than 1 million elevators. And the elevators now report their operation to Predix. So why do they do it? Well, for a very simple reason. Schindler puts an elevator in a building like this one, for example, and when that elevator breaks, they dispatch a team to go fix it. And that obviously takes time, and during that time, that elevator is not available, and movement within this building literally is impaired. Well, if we can get to a model where the elevator starts to say, essentially reports the readings on how it is moving, how the doors are moving, how the carriage is moving, et cetera, we can do predictive analysis against that elevator, and then be able to say, okay, I can change the service so that it actually doesn't break, right? It's a very simple, straightforward thing, very in concept. But remember, the world works on the following, which is that when something breaks, we then go fix it. Well, how if we change that model to, we think it will break in the future, and we'll do the service now. And that increases uptime and gets back to that essential thing which I put up on the first slide, increasing productivity. Very, very straightforward stuff. And the same thing, obviously, a lot of people lead directly into machine learning. And machine learning is one of those things that, again, the algorithms are quite old, but now that we're getting data from things like elevators and MR scanners and urban traffic systems and all the rest of it, we can start to apply machine learning algorithms to those to go and get directed outcomes. Whether it's improved healthcare or whether it's just merely in the fact that the elevator doesn't break. Something you don't even notice. And so APM, I'm just putting up a simple slide. APM is asset performance management. It's really just an application, if you will, that runs on Predix, but is increasingly used across the industrial world to go and say, how do we manage all of our industrial assets? That literally might mean this entire building, or it might mean a train, or it might mean an engine, if you will, or a windmill, for example, out on the hill. And the goal is really quite simple. How do we reduce the amount of downtime and increase the amount of uptime? And so going back to the city, LA, and it's true for New York and Boston and San Francisco. It's true for Kaiser Health System. It's true for Stanford Medical Center. Well, I actually shouldn't mention Stanford, I'm sorry. But it's true for UCSF. But all these different things, there are IT groups and researchers and principal investigators and everybody else who've been working for many, many years to go and solve their individual issues. And what we're now saying is that we have an opportunity to go and say, how do we address this essentially through the next level by providing a platform that allows for, frankly, all those other folks, and there are many, 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 many other cities and places and hospitals and transportation systems, airports, I won't mention SFO, that could use a little bit of today's technology to go and actually operate better. And so we're literally going from, if you will, building a platform to creating marketplaces for people to go and develop and publish applications and data analytics to address today's and tomorrow's industrial issues, which might be as simple as traffic, which still remains a problem, or might be as complicated as healthcare. So thank you very much.
We're going to break in a couple of minutes, but we have chance for maybe 1 or 2 questions. Yeah. For Peter, right in the middle there, guy in the check shirt.
Checkered shirt.
There's a mic coming through.
Yeah.
Hi, thank you so much for the talk. Super interesting. Quick question. Seems like the Predix operating system would require fairly good quality data coming in, to the flow, and then for you to be able to leverage all this cool functionality. Yeah. For example, I can think of the power plants or the example of you're talking about the street closures. Seem to me like it would need someone still to do the due diligence in the process. So how do you eliminate at the source of the data the room for human error and inaccuracies?
Okay, so I'll give a personal opinion. I don't think dirty data exists, right? And will always continue to exist, right? And the mechanisms that we have to deal with dirty data get fairly interesting, but we have a lot of them. You know, we have how can I best put it, the casual referee, which is the person who, you know, I'll use Waze as an example. Somebody reports a pothole, and then 10 other people are asked to verify that, in fact, that pothole exists, right? Really simple example. But there's always going to be dirty data out there. And you know, the reputation, if you will, of the data reporter, the metadata of the data reporter also travels with the data. So that's sort of the simple way that I would describe it. So here, I'll give you another example. That pothole, also Waze reports back to the city. I did a data sharing deal with Google, where every 4 minutes we get all the reports of everything that all the Waze drivers see across the city. It gets reported back to the city. So then, of course, the question then becomes, well, do you dispatch somebody to go fix that pothole because 20 people on Waze reported a pothole? And the answer is no. You wait until somebody actually calls you or uses some official mechanism to request service, because we decided, right or wrong, that simply learning that something is broken isn't necessarily enough to dispatch service at this stage. Maybe in the future it will be, but right now we don't really have the mechanisms to deal with bad data. And the reason, and here's an example where bad data really goes bad. You can get into denial of service attacks. You know, a bunch of people go around reporting false things, and they validate each other's false report, and now you've got crews running across the city doing things that they don't need to do, right? It's a classic denial of service attack in the physical world. So when we get to a better place, then you can start to say, well, dispatch service. So another question?
There's one more right at the back in the center there you will take.
Yeah.
Just wait for the mic, it's just coming to you.
Okay. How does GE fit into beyond predicts like, are you manufacturing parking meters and streetlights and everything to install? And do you find that that's important to be involved from the data collection through the analysis phase in order to really develop effective solutions?
Well, so GE, so we do streetlights, and in fact, the city of San Diego, for example, is deploying our streetlights. We don't, without meaning any offense to the light folks, the real value on the streetlights that we do is actually around the data side for things like environmental monitoring. These streetlights have things like, you know, cameras and environmental sensors and edge compute and all the rest of it. So they're more than a streetlight, if you will. They're really a compute node sitting on top of a pole that allows, for example, you know, to be able to do you know, parking enforcement or recognize that there's an air quality issue or things like that. But to the other side of your question, GE's businesses, we basically touch about 8 different sectors, right? Aviation, oil and gas transportation. We're the biggest producer of windmills and renewables and things like that. And each one of these, the business is basically, we produce a big complicated machine and then we service it for 10, 20, 30, 40 years, right? And the service, think of it just like your cell phone. You buy an expensive mobile smartphone, and then for, let's say, $700, and then you spend a couple $1,000s getting the service to it. Well, the same thing happens with jet engines. And so with a jet engine, what they're trying to do is at the same time that we produce a turbine, we produce a digital twin of that turbine. And the physical engine goes and flies around under Southwest and on British Airways or whatever it happens to be. And the sensor readings that come off of the physical jet engine are reflected back into its digital twin. And so you can imagine that the flight profiles for Southwest running around the West Coast are really different than, let's say, the flight profiles for an airline operating in Europe, for example, or in Asia. They're just different, right? Southwest specializes in doing many takeoffs and landings per day, right? Whereas other ones, you know, you fly across the country, that airplane maybe flies twice in a day. And so the wear and tear on the physical engine is reflected in the digital twin, and the digital twin then goes, it's really just a simulation. You can go and say, okay, when do I have to service the physical engine based on the data that exists in the digital twin? That's the sort of stuff that we're dealing with. And you can apply the same model to your automobile. You can apply the same model to this building, as an example. Okay, thank you so much.
Peter, thanks very much.